Next up, we want to evaluate this integral. And we're going to be using integration by parts. I know it's tempting to use the acronym here, where we have inverse, trig, inverse trig, algebraic, trig, exponential, logarithmic. And so we choose u according to this. But we're actually not going to do that. We're actually going to set our u of x equal to x and our dv equal to secant squared x dx. The reason that we're doing this is because it's easier to integrate secant squared x than it would be if we chose x secant x. And so that's just why we're doing that, because you typically want a dv that is easy to integrate and a u of x that is easy to differentiate. The acronym is just a quick way to remember which ones would be optimal to choose, but it isn't always true. And so now if we go about finding the derivatives, we find that du is equal to 1 dx, so dx. And we know that the integral of secant squared x is going to give us tan x, I believe. Yeah, tan x. And so now we're just going to put all of that into our formula. Let's just write out that formula. Integral of u dv is equal to uv minus the integral of v du. So with what we have here, we get that the integral of x secant squared x dx will be equal to x tan x minus the integral of tan x dx. And so now we need to evaluate this. So let's just rewrite it in its other form. You know that tan x is equal to sine x over cos x. And then we're going to use substitution here. And so as you know, if we happen to get it in the form of the derivative of f of x over f of x integrated over dx, we can simply set u is equal to f of x. That way, when you look for du over dx, which will be f prime of x, you'll get that dx is equal to du over f prime x. So when you substitute everything back in, the f prime x's will cancel and you'll just be looking for the integral of 1 over u du, which we know. And so that means that since we know the derivative of cos x is equal to sine x, we can do that here. And so we set u as sine x, which means that u as cos x, which means that du over dx is negative sine x. And this means that dx is equal to du over negative sine x. Substitute that all back in here. So we get the integral of sine x over u, and then substitute dx to become du over negative sine x. These two will cancel, leaving a negative. So we just pull it out to become the negative integral of 1 over u du. The negative is coming from that part. And so the integral of tan x dx is equal to the negative integral of 1 over u du. This is going to be negative ln the magnitude of u. Then just put back in u. So negative ln the magnitude of cos x. And so now we're going to put that all back into our formula here. Negative of a negative is positive. So this is just some of the rough work so you could understand where it's coming from. And so this will become x tan x minus ln of cos of x. And then now since we've gotten rid of all of the integrals, we can put the plus c now, since it's an unbounded integral. So we get x tan x plus ln of cos of x plus c is equal to the integral of x secant squared x dx. And that's your final answer.